We're going to flip this engine over, and don't forget, watch for escaping fluid.
About like that.
Yeah. Nice. Is that the big rat's nest fell out of there? Watch out for the rat. It's okay, the rat didn't survive because the rat actually went through a hole in the back of the block. There's an opening that goes down into the flywheel, and he was inside the flywheel.
Yeah, actually, you can see a lot of them right here.
Yeah, there's the rest of the rat. He didn't make it. Okay, let's get this oil pan off. Why did they turn our lights off?
It's closing time.
All right. Now again, no particular order in taking this apart. This oil pan is all aluminum and is part of the structure of this engine. Some of the later engines, 3.5s, had a plastic oil pan, a lower oil pan, but it had an upper structural part oil pan, so it was a two-piece oil pan. This is a one-piece, and as you can see, the bell housing this is actually part of the structure of the engine, and the bell housing bolts to the oil pan. So, and again, this will have pry points. You can see there's pry points here, because this is all siliconed on, and we're gonna pry that up. And there we go. Now we can see the bottom of that oil pan is full of.
There's a little bit of sludge in there.
A little bit of sludge. This with the condition of this engine with the varnish, this is about what we'd expect to see. Not terrible, but not great. You can see some of the sludge dripping into this engine and stuff. And this is our pickup screen. The large screen stops all the big junk from getting into the engine as it sucks up oil and it goes into the oil filter. So next thing we're going to do is we're going to pull this oil pickup screen out of here. And then we're going to pull the windage tray. And a windage tray is this piece of metal here. And what that does is it keeps the oil from being able to be frothed up by the crankshaft. All this thing does is pull oil. That tube's strictly there to pull oil from the bottom, lowest part of the sump. Okay. This should have probably an O-ring on this particular one. It'll usually have an O-ring or a gasket. Fun fact is you're trying to diagnose a car that doesn't have oil pressure at idle sometimes. Can be because that O-ring here could fail or a gasket could fail. And will give us all kinds of weird oil pressure issues. Okay, so this windage tray is.
Just let it turn.
These are part of the main bolts. Do you have anything longer to work on?
What was that?
Do you have anything longer to turn with?
I do, but
Why don't we? Okay.
won't be able to hold the engine stand.
Tough guy here. If you want to get Crystal, she just knocked that right out for you. Okay, these are 4-bolt main.
Six.
Actually, a 6-bolt main because they got cross bolts in them. But this is one of the two of the 6 bolts per main cap that hold this thing on. So we're going to pull this windage tray off. And I don't know the engineering ins and outs of this engine, but I would assume that this is part of the whole stability of this block. The early production of this 3.5 EcoBoost engine in the F-150 was a cast iron block with aluminum heads, but they later used an aluminum block with aluminum heads. Been a good engine. We don't have a lot of problems with this engine, just this particular truck. Okay, now we can see our crankshaft. Okay, see, we see our counterbalances, and if I want to show you here, remember we talked about this being an internally balanced crankshaft. See the little holes drilled in the crankshaft counterbalance there? They balance the crankshaft via those holes to be able to make this thing balanced. These counterbalances, these counterweights here, are all machined so that they can balance this crankshaft. If it was an externally balanced one, we probably wouldn't see any kind of balancing on the crankshaft. It would all be done on the crankshaft dampener itself. Okay, so I think what we're going to do now is we're going to pull a couple of pistons out of this thing, and then we will we'll pull a main cap and show you the main cap. Okay, we're going to pull a piston out of here. So we flip this thing back over and we put a couple of bolts, head bolts back in this. And what we're going to do is we're going to grab some rubber bands. And we're going to stretch some rubber bands, kind of double it up. We're going to put some rubber bands on here to catch that piston so it doesn't drop out of here. Okay? It's kind of a cool trick. We're going to flip the engine back over. We'll pull some rod bolts out. Get them far enough up so that they need to come up far enough so that they get past the rings. So it'll drop off there. Perfect. Just like that. Okay? Okay, we flip the engine back over again. Okay, now we're going to detorque that connecting rod. Okay, fun fact about connecting rods, they have to go back not only in the same hole they came out of, but they need to go in the same direction they came out of. Okay, most modern engines are going to come pre-marked, but you're going to, if they're not, if you're pulling apart, you know, Grandpa's old car, and it doesn't have any markings on that crank, on those rod caps, you need to mark their location, where they came from, and the direction which they came out. Okay, because if you try flipping them around, and we'll show you on this, we'll show you on the crankshaft how it's designed, they'll bind up in there, and you'll have a problem. These bolts here, too, are York torque to yield, and these are rod bolts. Okay, a lot of cars are going to be built with studs on the connecting rod, and you're going to have nuts on them. Okay, in that situation, you're not going to have to change the studs. They're not a torque to yield. But these are a composite rod, and they're a cracked rod. Very strong rod. We'll explain that here in a little bit here. We're going to pull that off, and we'll talk about the bearings. We're going to look at the quality of this. This engine was actually in very good condition. We'll get further into that bearing here in a little while, but as we take it apart, we just want to be looking for things that are a problem on this engine. Okay? So now we're going to knock that piston out. We're going to push it down. We're going to use something plastic or a wooden handle hammer. We're going to use plastic because he doesn't have wood. And as this pushes down, I'm going to get it down here, and we're going to. You don't have to catch it, man. The rubber bands are going to catch that piston. If you're going to push it out though, because it's right at.
I can't reach in there.
Well, that's why you have a hammer.
My hammer will fit.
I know it. That's why you're supposed to have a wooden one. And voila, we caught it with the magnet. Okay, so there we go. We have our piston. Really?
You get a week off. And then I get you a
And I'm not sure what we're looking at here.
No.
Okay, we're going to pull a main cap out of here so we can just kind of show you what's going on with the main caps. Remember, this is a 6-bolt main. It's got the 4 up on top and then 2 coming in from the sides. All part of the rigidity of the engine block. And again, just like the cam caps, if something goes wrong with any part of any of this stuff, you got to just change the whole cylinder block. You can't buy a new main cap or anything like that. Oh, you know, I was going to do a. You might have to. Okay, we had to actually pull all the side bolts out in order to get the block to let that come loose. So it's going to be the same thing. Again, it's unfortunate what happened to the rings on this engine because the bearings are in really good condition on here. The crankshaft's in really good condition. Focus on that a little bit, okay? Again, really important, the main caps, not only if they're damaged, they gotta be replaced, but they've got to go back in the exact same spot. Everything's fitted in here perfectly, whether it's the side, where they sit into the side of the engine here. Come on, focus. Whether they sit in the side of the engine or where they sit in the bore, it all needs to be in the exact same location when it comes apart. So now we're going to pull the oil pump out, so we can kind of show you what's going on with this oil pump. And this is just a crankshaft driven oil pump. Some oil pumps are driven off like a distributor drive, and this is just a G-rotor pump. And why don't you pull that apart and let's see if we can't get it apart and see let's see what's inside this baby and what makes it tick. Now in reality, if anything goes wrong with this pump, you're just replacing the whole pump. You're not going to ever need to take it apart. I want to see if we can get it apart, show you what's inside. Okay. Look at that. Okay. And this is what they call a G-rotor pump. And what it's going to do is it's going to pull oil remember, from here you see where that's coming, oil's going to come in here, and as this thing travels around, it's going to push, or, I'm sorry, you fell out of the video. Focus, come on baby, focus. Oh, there we go, just have to touch the right spot. Okay, and as the oil is going to come in, get sucked in through here, and as this squeezes down, it's going to come out and push it out into here, and out into the engine. Okay, and on here we have a pressure relief valve. If this makes too much oil pressure, it just simply dumps oil out this passage back into the oil pan. And very simple, very reliable pump. Okay. Okay, I just want to guys show you how this thing's been cut on the sides in here. They've got little reliefs in the corner in here. And then we're going to show you the oil passages that come through here. We'll roll this engine around. Okay. So this is a main somewhere in here. I gotta find it. Where is it?
You're on it.
Is that the main? Yep. Okay. This main bearing has an oil hole here that it goes down and comes into the rod bearing there. You got anything small that you can get all the way, will go all the way through there?
No, I don't have anything.
Okay. Well, yeah, take my word for it. They cross drill those, so the oil is going to flow from the main bearing to each of the rod bearings, and each rod's going to get oil up to it from the main bearing. The other thing, I don't know, did I mention it earlier, that this was a internally balanced crankshaft that has holes in here. All these holes that are in here are from them drilling to balance this crankshaft. If this was externally balanced, we'd have a harmonic balancer that was keyed to it. They would have balance. They would have a weight on there to balance the crankshaft. This one's internally balanced. Okay. Anybody have any questions that's here about what we're looking at? Come on, somebody ask a good question. All right. Remember, we have our crankshaft flange. That's where the flywheel is going to bolt to, and we have a rear main seal, just a full rubber rear main seal. And this rear main seal is actually part of a big plate that goes along the back here. And when we change that out, it just changed the whole thing out. Okay.
I don't know if you can see the thrust washer in there. The thrust
And-
bearing. Right in between.
If I can pick it up, we're trying to find there's a thrust bearing in there. And what that thrust bearing is doing is it's keeping the crankshaft from moving forward and backward, keeping it from having too much in play.